Welcome. Today I am going to be talking to you about loops. But first, let's talk about plagiarism and copyright law. A definition of plagiarism can be found at the bottom of the SUNY Suffolk Library website. There, plagiarism is defined as to steal and pass off the ideas or words of another as one's own, or use another's production without crediting the source. For more information on plagiarism and how to avoid it, visit the link below. This presentation may include music, images, and other forms of art to help guide us along. In order to protect the authors of any copyrighted media, we will be complying with the Digital Millennium Copyright Act by using royalty-free works. The Business Dictionary defines royalty-free as the ability to use intellectual property without paying a royalty fee. So, royalty-free refers to any production, such as music or photography, that an author provides without charging a royalty. In this presentation, we will learn what loops are, how to calculate them, and most importantly, how they relate to computer majors. In mathematics, loops are displayed as following, where sigma is the symbol letting us know we are computing a loop. The function of I is any function. N is the upper limit. I equals 1, or any number, is the lower limit. So, to compute a loop, we simply calculate the functions fi, where I is every number between the lower and upper limit, then add up each answer, giving us the value of summation. The end result should resemble the following. Before we dive into actual problems, let's discuss how this relates to computer majors. Whether you plan on becoming a programmer or not, at some point you will be introduced to a programming language, and you will be coding loops. In programming, loops look different, but the basic concepts are the same. You have a marker that lets you know you are working with a loop, a lower limit value, an upper limit value, and some sort of equation or code that will be executed over and over again until the upper limit is reached. Now that we have an idea of what loops are and how we will use them as computer majors, let's work out some mathematical problems. To compute this loop, we begin by creating a table which will look like this. We know from our expression that the upper limit is 3 and the lower limit is 1, so let's type that in as follows. Now we simply substitute the values for I into the expression, like so. And finally, we can calculate each expression. But we're not done yet, because we still have to determine the value of summation, which will be our final answer. To do that, simply add up each answer as follows, giving us a value summation of 6. When programming, you may run into the need for a nested loop, or a loop inside of a loop, which will look something like this. You can also calculate nested loops in math, which look like this. In this case, you have to account for both values of I and j. For example, this time we make our table a little differently than before. Our upper limit and lower limit for j are -1 to 1, so we add that to the table under j. But now it gets a little complicated, because f of j is nested in f of I. So what we have to do is loop f of j for every value of I as follows. Now we substitute the values for I and j and calculate the expressions. Finally, to get our answer, we add up each solution to give us a value of summation. which in this case happens to be 0. This concludes our video on loops. In this presentation, we learned how to calculate both single and nested loops, and in doing so are now more prepared to move on to learning how to code loops in our programming courses. Except where cited, all information in this presentation is original, and any media that was used is royalty free.